Hello guys, this film will be about rebuilding old battery pack. Uh, this is one of the battery packs, the first one I bought. It was originally in this high-long case. This tray reaching actually half the length of the battery. So I was using this battery pack for, let's say, 3-4 months, and then it started failing for no reason. Cutting of the motor and loss of the power. So I decided to rebuild it, try finding the cause of it, and then rebuild it actually to the different format case. That one, called also like a poly, with the tray all along the battery case. So this shape format is a little bit better, and especially like, you know, the battery box tray, where you have slots all the way, so actually you can utilize the bottle screws on the frame, connect them here. So here you can see the whole battery pack connected, all the cables. I already identified the problem. There are loss of connection between these metal strips and the battery cells. You can see that I marked them with the black dots, like this one, this one, this one, and on the other side here. You can see it's completely disconnected. There might be problem also with the BMS. But since I see there are loss of the connection between the battery cells and the strips, I have anyway new BMS, so I will be using this in the new build. Alright, one of the quickest ways of checking if all the cells are alright or not is checking the potential difference between different cells groups. You can use a simple multimeter for this. I'm doing this by starting with the first cell group connected to the black cable, which is like in the 0 level, you can call it. And then I'm going just one by one between the groups. The nominal voltage for one cell group is 4 volts. You can see it here on the multimeter. So if I'll keep jumping from one cell to another, you'll see the voltage increasing in 4 volts increments. You can see now we have 12 volts. Going on the other side, 16 volts, 20 volts, 24, 28 approximately, as you can see, 32. You can see that they are not fully charged already. 36 approximately. Here on this portion now, and you can see already problem with this cell group. No matter what side I'm using, you see the same voltage, 36, and that's not good, because you should see the increment of the voltage of 4 volts. So that means that this group is bad. I have 0 voltage, and I hope it will be enough just to recharge them to the full capacity. If not, then I will have to replace the cells. Now you can see I'm disassembling the metal strips from the battery cells. As you can see, it's important to wear protection equipment, gloves and glasses. These metal strips are very sharp, so it's easy to cut your fingers, and there is always a potential for like sparks. So I need to protect my eyes. Strips are going quite easily. I don't have to put excessive force to this. Important is to not touch another cells when you are taking them off. You can see how poorly made this back is. The cells are, some of them are glueless, some are not, and there is no protective gaskets on the plus poles on these cells. And very good quality. Alright, you can see the battery pack disassembled. All the strips are removed, and I already do some testing of the voltage of the cells. So I already indicated with the cells with almost zero potential. They're marked with these black stripes. There's just a couple of them. Mark it on the plus side. This one, this one, this one, this one, this one. I'll show you quickly what is the potential. So the good ones has around 3.8 to... you can see this one has 0. Maybe you can see better light here. This is bad, so this one is alright, more or less. This one is empty cell. This one is empty. This one is empty. Go further. This one is empty as well, marked. This one empty. Empty, empty. Go further. This one empty as well. This one was alright. You see the voltage jumps to 3.8. So this is a very quick check of which battery cells are alright and which are not. So I'll put this on charging. Special charger for the lead ion cell battery packs. So if they are right, it's just if they are just empty and no damages, they will just recharge, and then I can reuse them in the new battery pack. Here you can see all the batteries separated with the good ones, with the empty ones. These are already prepared for charging. Here is the battery case I'll be using. So once all of these cells are charged to the same level, I will start the assembling process. Okay, after a couple of days of charging these batteries to full capacity, now is the time to start assembling the whole thing. Here you can see the setup, all the elements, almost all elements required to build a new battery. I didn't put all the cabling because, yeah, I don't know how many cables I will need for this. Be like done when I'm done with assembling the battery. So maybe I will start quickly showing you what items will be used in this build. Maybe I will start with this picture, which shows the layout of the cells for 48 volt battery. So what you can see here is the position of the nickel strips, which are connecting the plus and minus of each cell, and these metal strips are grouping the batteries in parallel and then series to achieve required capacity and the voltage. So if I'll take a closer look, you'll see I already mark up each battery group, I can call it. I will not describe this in detail, so this is quite complicated and varies between batteries, but you can find a lot of information on the internet for this. Here you can see these metal strips used to connect the poles of the batteries. So what else? Here is the battery case with this black plastic cells holder. There are two of them. So what I will be doing will be putting these cells in each cell with correct orientation of plus and minus. Here are other parts of this case. As you can see, the connectors. This is like a charge level indicator. So a lot of things needs to be talked about, so I will not go into details about it. What else? Here you can see the BMS, two types. Both of them are rated till 30 amps power and 13 cells groups. Here are the connectors to each cell group, so this helps balancing the battery during charge. Here are the cells, and this is the spot welder. Okay, so I already mentioned something about the cells groups. So what I'll be doing now will be putting the cells or the batteries to each location. So according to this diagram, this shows me where exactly to put each battery. So I will start with group number 1, and then I will go to group number 2, group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in total there are 13 groups. So it's quite simple, you are just putting it with correct orientation. So starting with the minus pole, like this one here. And here, I will not use these ones because they don't have protection. There's another ones. By protection I mean this paper on the plus of the battery. This protection is used to protect the cell from a short circuit between plus and minus. Without this, when the plastic strip is cut, can connect the battery and the battery can get fire. So this is quite important to put it on. So here you can see the first group. I will continue like this with others. Okay, now you can see the fully assembled pack, the cells in place with the correct orientation and grouping. It's quite compact. So that's how all the batteries looks like. And now be the process of installing these metal strips on top of each group. And this will be each cell, each metal strip will be connecting two groups together, like a minus with plus. And for this purpose I will be using this spot welder. Okay, I already started welding the groups together. Here you can see the first one assembled. Minuses of the first group. Now I'll be connecting group 2 and 3, plus and minus. You can see it better like here. You have to be very careful with it. Just always double checking if I'm connecting the proper cells. And then we go. It's quite simple. You can see already 3 cells connected together, and this whole process looks the same for all the other cells. Alright, you can see the first side finished. Looks very well. The spot welder is giving good welds. So now I'll be doing this side. And basically it will be repetition of the stuff I did on another side. Okay, now is the next step to install the BMS on the battery. Here you can see the diagram, how to connect all the balancing leads, which are here. Maybe I'll show you the cable. So this is like the balancing cables to each cell group. This cable goes here, and you can see how the connectors looks like. So basically they are connected between cell 1 to cell 2, 3 and so on. And what you can see on the battery, I made these nickel strips for connecting these small cables and the main minus and plus of the battery. Here is the minus, here is plus, or charge or discharge. Yeah. So now will be soldering time. Here you can see soldered all the cables. So plus, minus, all balancing cables. in place. So I'll protect them with these rubber tubes, and then the final step will be connecting the BMS. Before I will connect the BMS, let's work to check that all the groups are separate, having the proper voltage, and there is increase in voltage in the proper way, I can say. So like going, when you look at the cable connecting to BMS, each cable should have like increase in the voltage by around 4.1 volts. These are fully charged batteries, so they have a higher voltage than the nominal one, which is 3.7 for lithium-ion cells. So here you can see the test setup. I connected the ground to the voltmeter. I'll be just going step by step for each cable. And then you will see on the screen increases of the voltage. So starting with the first cable, this is like the ground cable, so you see the potential is 0. The first group 4.1, the second one 8.3, third 12.5, fourth 16.7, and so on, so on. So going step by step, you see the voltage is increasing. And already 50 volts, and the last group I reach 54.7 volt. Okay, so now you can see the fully assembled battery. There's a lot of soldering of cabling. So here you can see BMS installed underneath the battery. So all the ground cables are connected, balancing cables as well. What I can say, you can see the layout is quite complicated of cabling. The main point was the circuit breaker is between the discharge line, on the discharge line, and the charging port is permanently connected to the battery, so it will be possible to charge the battery without turning it on and off. So what else you can see here? Here is a display showing the status of the battery, so it's connected to the discharge port. I need to combine these cables somehow, so they will not be protruding into these mounting holes. So you can see the build is very neat. I didn't make movies of all the last installation steps. There's plenty of tweaking of the cabling, so I skipped that part. It's quite complicated and differs between the battery types or the groups, and what sort of connectors you have on the housing. So now I'll put everything together and see if it works. So this will be the last part of this whole movie. The battery is completed. I had some problems with cabling routing, but this is sorted out. So you can see here is the power button. Here indicator of the charging level. You can see the battery is fully charged. I'll just show you quickly the voltage test. Should be something above 50 volts. Yeah. 53.8 volt. So battery works. I already tested it on the back. And this is very nice box. Okay, thanks for watching.